Hey, and welcome to a guide to event-driven SRe-inspired DevOps, a presentation I gave at the online Kubernetes meetup on the 29th of July. I'm recording this again because we had some challenges, technical challenges when we recorded it live. So for all of you who couldn't join live or who want to rewatch it, this is the same thing I did at the end of July. Now, a guide to event-driven SRe-inspired DevOps. I know this is a mouthful of buzzwords. I put it there for a reason, but it's not just to make a lot of noise about nothing. I think there are a lot of things that I can tell you today, and problems that I want to raise, and also solutions to those problems as it comes to a modern approach to delivery and operations. The core tool or project that I want to use for this is Keptn, a CNCF sandbox project. You can find more about Keptn on the links on the right. Would be great if you follow us on Twitter, star us on Git, obviously only if you like what you see and if you think we're actually solving problems that really need to be solved. My name is Andy Grabner. I work for a company called Dynatrace, and you can also find more information here. At the meetup, we started with a polling question, and you can read for yourself, but I think now as you watch this offline, you may want to quickly reflect on this question and answer it for yourself on how your current continuous delivery implementation looks like. Is it very hard to troubleshoot broken pipelines? Is your pipeline heavily customized? Do you have still a lot of manual steps out there from dev to prod, or is everything good? At the meetup, we had answers where I think answers number 2 and 3 were ranked the highest. So a lot of people are still having or challenged with heavily customized pipelines that are hard to maintain and a lot of manual steps. Even though I have to say, I think we had about 20 to 25% that also answered number 4 as their answer, which means delivery seems to be good for at least a quarter of the people that we had. So that's great. So, take this for yourself. But what I took with me from this survey, a lot of people are struggling with very hard and complex and hard to maintain pipelines, which brings me to the first problem that I believe we need to solve in our IT industry. This is classical monolithic pipelines are hard to maintain. And the solution for that is we can break the monolithic hardwired delivery pipelines into smaller pieces, into the individual steps, and then have an event-driven control plane on top to really make sure that the individual pieces are orchestrated or choreographed. I also like that word a lot. That individual steps along the delivery pipeline are executed through an event-driven model so that we can do continuous delivery without having everything hard-coded in one big monolith. And we know how monoliths, also from the software world, are obviously a challenge to maintain, to find problems, and to push out something new. All right. Let me give you a little more detail on this problem, right? Because maybe you say, well, this is not a problem. I've never seen this. Well, I've seen this many, many times in my life. This is a rather simple pipeline, a screenshot from a Jenkins pipeline. It's around 350 lines of code, not yet complex because there's pipelines that are even bigger, but still the fundamental problem can already be seen here. There's mixed information about the process, the target platforms, the environments, and the tools that are used is hard-coded in that pipeline. And also, because of everything is meshed into one Jenkins file, in this case, there's no clear separation of concerns, right? There's no clear separations for what the developers are interested in, the DevOps engineers are interested in, and the SREs are interested in. Everyone has access to this file that needs to make changes. And so essentially, I could go in as a developer and I say, I just remove maybe the test phase because I didn't do my tests properly. I mean, I know there's other ways of doing that too, cheating, but I think you get the idea. So this is a big problem. Now, the problem, though, is not a single pipeline. The problem is if you start out with a single pipeline and then you copy it and slightly modify it for individual projects, as you can see here, right? You change small things because the rest works well, but then you add a little piece here, you add a custom tool integration here. Well, this is a different environment and it needs a different way to deploy into. And then this then gets obviously multiplied by as many teams as you have and as many services pipelines you have. So we have this classical snowball effect or snowflake effect where you have a lot of different permutations. And exactly here, it's very hard in case something is wrong to figure out what was this pipeline actually supposed to do? Who came up with this particular stage, with this particular step, with this particular integration? How can we get this back to normal? Why did it even break, right? Was it an update of a library, of a plugin or something like that? So this is a problem we want to solve. Now, if we look at the solution to this, how can we solve this problem? If you look at most pipelines, obviously we have a process on the left side from top to bottom: build, prepare, deploy, test, then maybe notify somebody, and then eventually roll back in case something is wrong in production. But the hard coding here, the hard coded wiring to the individual tools is the issue. So what we want to do as a solution is we want to get rid of these hard coded, hardwired dependencies so that we can separate the process definition, right? Which steps should be executed in which sequence? Do we need tests? Do we need to notify? What do we need to do? So that the process definition from the actual tooling. So we separate it, but then obviously the tools need to be invoked at a certain stage. So this is where eventing comes in. That means we're just using concepts that we also know in software engineering, where you have event hubs and somebody is triggering an event, and then whoever can work on that event is picking it up, is doing something with it, and is sending back the result, and then triggering the next step of the workflow. So to give you one example here, one of these events could be, hey, I have a new container and I need somebody to deploy this in the dev stage using a blue-green strategy. So if you send that event into this event hub, and then a tool that can actually do this can take it and say, I'm doing this, I'm deploying, and then responds with the result, this is already a great decoupling, because you have a process definition and then tools that can then actually do it without having everything hardwired. So in the end, what's really important is we need to figure out which events do we actually need in modern continuous delivery. Is it just these 6 that I have here, or are there actually more? And also which tools should then react to these individual events. And the great thing is, if we do it right, it's also very easy then to replace individual tools, right? You can say, I'm switching from deployment from my Jenkins pipeline to, let's say, Spinnaker. And then the only thing you need to do is you just need to say, I want Spinnaker to listen to this event and no longer Jenkins. And then you have completely replaced the tool without having to modify any code in a pipeline. So the way we solve this with Keptn is the open source framework I've been talking about. Keptn has a control plane that basically executes the logic and the workflow, and it's using eventing for it. For the eventing, we're using nets, and you will see this later in my demo. What we have on top of that, so you install Keptn, you got the control plane, you got an API to interact with, you also got the UI. But in order to tell Keptn about the process, we can tell Keptn about what type of stages we have, what should happen in these stages through what we call a shipyard file. So application plane, it's basically that defines the process. In this case, you can see here my example, I have dev, staging, production. I may have a direct deployment with functional testing in dev, and I have a canary deployment in prod, and release user tests, meaning a real user test, meaning I'm not running any tests, just using real user feedback. So that's the application plane, defining the process. Then you also have the execution plane, or what I also want to call it, the tool definition. So which tools should actually then do the work in case Keptn needs some work to be done. The tools range from different sets, config service like Git, deployment like Helm, Jenkins, test services, and so on and so forth. In Keptn, we call this a uniform. So which tools are part of the uniform of the Keptn, right? And for which events are they interested in? So for instance, I have an example here, configuration change events. If somebody made a configuration change, meaning let's say updated the Helm charts, then the Helm service can pick this up and then do the deployment. Or if a deployment is finished, then maybe you have JMeter executing some tests. So the idea here is, what type of tools are in my tool belt and which events should they act upon? Now, the beneficiary of all of this is the developer in the end, because the developer can say, hey, I got a new artifact and I want to send it through the process that has been defined, let's say, by the site reliability engineer, and the tools should be used that the DevOps engineer has defined. And so the way this works, the artifact gets sent off, and then Keptn is sending all the different events And with this is triggering the different tools to do a particular task and basically move the artifact from one stage, from one phase of the process to the next, to the next, to the next. So some examples, as you can see here, everything typically starts from end to end for an end-to-end delivery with a configuration change event. So I have a new artifact. This could be picked up by Helm. If Helm deploys it, or it could also be a Jenkins. We're flexible here. You can put in any tool. I know we had questions throughout the live presentation about how does this compare with Spinnaker, and I said, well, Spinnaker is a great tool for delivery, so you may want to integrate Spinnaker with Keptn, right? You don't necessarily have to use the out-of-the-box deployment option that Keptn comes with, which is Helm. You can use something like Spinnaker if this suits you better, or you can also call your Jenkins pipeline or a GitLab pipeline or a Harness pipeline. I don't care. Right? That's a great thing. But as you can see here, the artifact is basically moving along, and these individual tools are listening to events, doing a job, and then sending back the result, which then means the Keptn control plane can move the artifact further along. Now, this brings me to my first demo. I have event-driven, I call it event-driven progressive delivery with Keptn. So what I have is a Keptn installation. Keptn get installed on Kubernetes. In my case, I have installed it on EKS. You can also run it on any Kubernetes flavor, also on OpenShift. And we have some tutorials where you can run Keptn in a box. We call it Keptn in a box on micro Kubernetes, or also keys. That's K3S. So I have 3 stages. I also have a sample app that I have built. It's an app that I built years ago, copy and pasting code from somebody else, modified it a little bit, gave it different background colors, my 4 different versions. I also put in some different features in my apps. So version 1 is great. Version 2 has severe functional problems, is failing all the time. Version 3 is good again. And version 4 is also good in pre-prod, but in production under certain load condition, it fails over. And this allows me to show different aspects of progressive delivery, where we say a version that is really bad, and it's clear it's bad, should never make it into prod. A version that is good, but maybe has an issue in prod, I want to show blue-green deployments here, right? And that's what I'm doing. So in order to kick off a process, I basically just say, Keptn, I have a new artifact for you. And this will send an event to Keptn, then Keptn starts its workflow in doing all the magic, like it first actually makes sure that this configuration change request, like my tag, my new image, is stored in Git. Keptn internally holds Git. Has a Git repository where all the configuration files are stored. So all the Helm charts are there, my test files are there, and so on. And if I make a configuration change through the CLI, this update will obviously be version controlled. Then in my case, I'm using Helm. I specified direct deployment, so it will do a direct deployment. After that, JMeter will kick in, again, through the eventing mechanism. And once that is done, with a core component that we call the quality gate, it's actually done by the so-called Lighthouse service in Keptn that will then come up with a quality gate status or a score between 0 and 100 that then allows us to say, do we want to promote this to the next stage, yes or no? In my staging stage, I've specified automated approval. That means everything that is good automatically goes into staging. And then the process starts from scratch: Git, Helm, JMeter, quality gate. Now for production, I've decided to use manual approval. Why that? So we built this in as a recent capability in Keptn because we heard a lot from a lot of early adopters and users. They said, it's great that you can automatically promote, but in production, we would rather like to have a human being still checking off the box. And that's what I've also done in my example. Now you have to manually approve or allow a previously tested and approved artifact in staging into production. But you click on it and then the same thing goes on. In my case, I'm using blue-green deployments as a deployment strategy. So our Helm service can do blue-green deployments, then executes JMeter tests, does a quality gate again. And in case everything is good, it will keep it there. Otherwise, it will roll it back. All right, let me go over to my demo. So this is my Keptn installation. So actually, let me show you this. So I have different versions here that are deployed. Let me just quickly refresh. Services, build number 3. Here we go. Build number 3 is in dev, is in staging, and in production. So that's all great. I think because of a previous test, I have a couple of previous artifacts that are already kind of lining up for being approved. Let me just cancel them out. It seems I'm doing too many tests these days. So everything is good. I got build number 3 deployed. By the way, if you want to see my build number 3, this is how it looks like. Not a very fancy app, but it's deployed by Keptn in my EKS cluster. It's also monitored by Dynatrace, which is important for the quality gate aspect. Now I use Dynatrace because I have an affiliation with Dynatrace, but you can also use Prometheus or any other monitoring tool. For Prometheus, we already have an out-of-the-box integration with Keptn. For other monitoring tools, whether it's a Datadog, whether it's a New Relic, an AppD, I'm sure there's many others out there, feel free to just build a Keptn integration with your monitoring tool. Very easy to do. All right, so I got these 3 stages. Now let me show you a little bit what's happening behind the scenes. When I set up my Keptn project, you start with the so-called shipyard file. Remember that? So this is my shipyard file. Okay, so I specified my dev stage, direct deployment, and the test strategy is performance quick. So I have different types of JMeter workload definitions. One is called performance quick. And when Keptn later on sends the, hey, it's time to test the software that was just deployed, it passes in that event the definition here, let's say performance quick, and then the JMeter service can pick up the right workload and execute it. So dev is here. Staging. In staging, I say direct deployment strategy again, but then a different test strategy, performance peak. That's a little bigger test. And then I also have an approval strategy. Remember what I said earlier? I automatically allow everything from dev into staging that has passed the quality gate. For those that have a warning, I still have to manually allow it, right? That allows me to say, if somebody completely messed up dev, I'm not allowing this into staging. And for production, let's start first on the approval. I do manual approval all the time, whether pass or warning, because maybe this is my requirement. Then I do a blue-green deployment strategy. I again run some performance tests. And then also we have a remediation strategy. And this is another key aspect of Keptn that I will come to later, but it's about automating problems in production. If something happens to be in production for a while, and then a problem happens, we can also do auto remediation. So this is my shipyard file. What Keptn also does, I told you Keptn holds Git, has a Git internally, but when you create a project, you can actually specify an upstream. And that's actually my upstream here. I'm using my GitHub project here. And what's important, for every single stage that I've specified, dev, prod, and staging, Keptn automatically creates branches. So let me go to the staging branch. Excuse me. Here you can see files that are relevant for this particular stage. Like for instance, under simple node, I have my Helm charts in here that I've uploaded initially, and then depending on the deployment type, Keptn also created the necessary umbrella charts. In case you do blue-green, we leverage Istio, your Istio if you have Istio, and then also create the virtual services and so on. So this is in here. I got my JMeter stuff in here, my load test, my basic check, and here is the whole workload configuration. And I'm sure you remember earlier I had performance peak and performance quick, I believe. So this is basically then defines what type of test should really be executed depending on the test strategy. And what else do we have here? Yeah, in my case, I just have I'm using Dynatrace for monitoring, and here's some SLIs and some dashboards that I will show you later. But this is really what it is, right? Everything is stored, everything is maintained in Git. And now if I want to build or deploy a new version, then I have 2 options here. Well, I have multiple options, but I show you the ones that are typically used. So I could say I have a new artifact that was built by your CI and pushed to the registry, and now I can notify Keptn about it. One of the options is to use the Keptn CLI, Keptn send event new artifact for a particular project, for a service. I have a new container, so I could now send build 4 along the way. The CLI itself is just making an API call to the API endpoints of Keptn, which means if I quickly take this URL and open up a new tab, and let's go to the API. So, you know, it's pretty sure you are familiar with APIs, but we have the option to basically, interact with the configuration element, so you can upload files to the Keptn Git repo. We have a lot of different endpoints here to upload project resources, service resources, and so on to create projects. But what's very important here is actually this one, the post event. The post event is where, as an external tool, can send Keptn an event like, hey, I have a new artifact. I want you to do a certain thing and kick off a workflow. And because that's available, and because I showed you that this is possible, but I know in the last session we had a couple of Jenkins fans in the call. Actually, they were just making joke of Jenkins, but for that reason, I also want to use Jenkins now. So let's assume you're using Jenkins for your CI, you build your containers, and then you put it to the registry. And what I've done here, I've just created a very simple Jenkins pipeline to just show that you can trigger these things from Jenkins as well. So it could be your existing Jenkins pipeline where you just make a simple call. And I say here now, hey, for my Keptn 07 project, remember this is this project here, Keptn 07 project, for the simple node service, my simple node service, I have a new image, and actually version 4, that's what I want to, and then build it. So what happens now, an external tool like Jenkins is telling Keptn, please go along and do your stuff. And now you may wonder, this was also a question from the live audience, so do I see what's going on? How do I know which tool is actually engaged and where things may break? Because you may still have breaking things, right? So yes, this is where the services tab comes in. So on the services tab, what you can see here is quick overview. I only have one service in my project. You can have multiple services. Service definitions behind every service is obviously something that you typically either want to deploy, Keptn to deploy, or you want Keptn to validate a quality gate or self-heal. Now I have one here, and build number 4, this just came in, right? So you will see, or we will see here, the individual events that Keptn is triggering. So it's kind of like my trace log through everything that happens. Starting with a configuration change event that was triggered by Jenkins. Jenkins can also push in metadata, we call them labels. So I know it was build number 27, it was triggered by Andy, the job name, and so on and so forth. And now it will go on, and then we'll start deploying, and then here we go, deployment finished. That's great. So Helm just deployed. Click on the link. Now we can see build number 4 is in dev. That's great. Next thing that will happen is it will run through some tests, then the quality gates will be evaluated, and then it will hopefully be promoted. Right? Now, if we go back to environment, I can also now see build number 4 is also in dev. And yeah, we should see more as this thing runs along. But what I wanted to show you is really how we have separated the process definition, right? Remember, there was my shipyard file. Where is it? It's my master, my shipyard file, right? So this is my process definition. The tools, let me just quickly go in here. If I do a, I'll need to execute this one here. Let me do a KK get pods, in case KK is a kubectl for the Keptn namespace. So here are all my my currently installed services. So I have Dynatrace in here, I have Helm, I have JMeter, I have my remediation service, and so on and so forth. And so these are basically the tools that I've installed that are listening to these events. Now we have more. We have a JMeter service where Keptn can trigger JMeter. We have services for Slack, where you can push notifications to Slack. We have a service for GitLab, trigger a GitLab pipeline, one's for Azure DevOps. So there's already a couple of those out there on the Keptn GitHub repositories, and nothing keeps you from writing your own. It's just a very simple service that is registering to an event, gets triggered when the event comes in, then decides what do I need to do with it. Every service has full access to all of the files that are stored within the respective stage and within also their respective folder. So the idea is that you are For every service, you have a subfolder, and then for every tool, this is where you keep your files, right? And if you happen to have these files already somewhere in your existing Git repo, nothing keeps you from just sending these over to Keptn as you are launching Keptn or as you're triggering Keptn. That's also what we see with a lot of people that are using Jenkins. They are building their stuff, pushing the build container to the registry. Then before triggering Keptn, they say, hey, Keptn, by the way, here is the latest JMeter script from the source code repo, and here is another config file. So we push everything up to the Keptn repo, and then these individual tools can go off and do their magic. Okay, good. Let's just see if there's anything else. Yeah, things are running through. It's already in staging. That's awesome. Okay, which means we have build number 4 in staging as well. Good. This was the first problem that I wanted to highlight. Also a little user example. I talked so much about Jenkins, but now I actually use example using GitLab. So Patrick works for Amazon. They're using GitLab for CI. They are building their containers and pushing it up to the registry. And after that, they are triggering Keptn, right? And they are then using Keptn's delivery assistant to push their artifacts to dev, staging, and production. And they also leverage the fact that Keptn has the quality gates, bottom left, I'll come to this in a second, and also integrations with Dynatrace because they're using Dynatrace for monitoring. So every time Keptn deploys into any stage, the monitoring tool also gets notified about who deployed what at which time into which stage, which then helps whoever looks at monitoring data to figure out why are things acting up weird. All right. Problem number 2 that I wanted to address is there's too much manual effort in deployment validation. So what does that mean? We have seen that a lot of people have built pipelines, yet when they have a new artifact and they deploy it, then they run some tests and then they have to manually look at test reports, at the logs, at the monitoring data to figure out is this a good or not a good build. And there's a lot of manual time wasted. And this is why the solution here is we want to leverage SLIs and SLOs, which is something that Google has been, especially Google has been promoting through their SRe best practices. But there it's typically for production monitoring, for production alerting and production reporting, but we want to use it for quality gates as well. Now, what that means, first of all, a quick primer on what am I talking about, SLIs and SLOs. Maybe you've never heard about it. Nothing that I came up with, but to keep it very simple, SLIs, service level indicators, it's basically just a metric that is important for you, like an error rate of your login requests. So you have maybe an authentication service and you have a login API endpoint. You want to know what the error rate is, right? You want to measure this. Now an SLO is a binding target for your SLI. So for instance, the login error rate must be less than 2% over 30 days period. Right? That's something that you get measured against, because if your login doesn't work, then you may have problems in production if people can't log in. Now, SLAs are then typically business agreements between consumers and the provider of the service. But in this case, it often goes beyond just a single SLO. It sometimes contains multiple SLOs, like logins must be reliable and fast, which means you're looking at error rate, response time, throughput, and it has to meet the criteria 99% of the time within a 30-day window. Otherwise, you may get penalized or you lose customers or something like that. Now, if you want to learn more, I can really encourage you to watch this video. It's called SLIs, SLOs, SLAs, oh my. It's a YouTube video from some of the Google SRe engineers. It's really, really, really worth watching. But what does this mean now for us? How can we solve this problem of it takes too long to approve a build? Now, remember, SLIs and SLOs are typically analyzed in production. So this is a screenshot of how monitoring tools, like this is a screenshot from Dynatrace, how monitoring tools are implementing it. So you can say, I want to know how is my SLO for my authentication service? And then you get things like, are you on target? What's your error budget? And so on. But essentially what it means, on a month-to-month basis, you're looking at key metrics like throughput, failure rate, and response time. And every month you get indicators on how well did you measure against your SLOs. And you can do this for every type of service. And again, typically you have monthly reporting cycles on that. But what we said the concept itself, it's very popular in production. Why can't we just take this and shift it left into continuous delivery? Because essentially it's looking at metrics, comparing them against the threshold, and then coming up whether you're meeting your targets, yes or no. And then you do it not on one, but maybe on multiple metrics. And the combination of it tells you if you're good or not. That's what we do with Keptn quality gates, which means with every commit, with every time you're pushing something through Keptn, we're looking at your metrics and then we are scoring them. Right, with a scoring mechanism. Now, obviously, the time frame is not a month, but the time frame is now the time it took to run the test against this artifact that you deployed. Right, that's important. Different time frame. That's also why you probably have, different goals. If in production you have a goal of, let's say, 1 million users throughput, it can handle 1 million users. You may not simulate 1 million users in your CD, so you need to adjust these thresholds. Now, what we've implemented with Keptn quality gates is not only static thresholds, but you can also do it relative to previous builds. This is great for regression detection. So you can say the failure rate should not increase from build to build, or the number of database calls that are made should not increase by more than 10% from what the baseline was in the previous builds. Right? And again, we can do this for every service you're pushing through Keptn. A quick example on how this looks like visually. So SLIs, you specify them. Again, these are your metrics, and you specify where the metrics come from. Could be, in my case, Dynatrace, that's a Dynatrace query. It could be a PromQL if you use Prometheus, and it could be any other data source, because Keptn, you can use and define different SLI providers. Again, right now we have 3. We have Dynatrace, Prometheus, and we have Neotis. And you can, feel free to come up with your own SLI provider for your tool of choice that provides values. And you specify the SLIs. You then define your SLOs, again, either static or relative. And then you also specify an overall goal, because what we do, we look at every single SLI and then evaluate it and then come up with a total score between 0 and 100. And to give you some example, on 4 builds, build number 1 comes along. If the metrics are all good and everything is green, that's great. That means we get all the points. That means 100%. Build number 2, we got 2 warnings. Warning means you get half of the potential points. Red means 0 points. So in this case, we get 2 for green and we get a half and a half for the warning. So overall, that makes it to 75%. Build number 3 comes along. It seems the first 2 problems have been fixed from build number 2, but now we have twice as many calls to the backend service, right? So we also include metrics that tell you more about the architecture, how many backend database calls do you make, how many third-party services do you call. If your monitoring tool supports it to give you these metrics, then use it, right? In my case, Dynatrace tells me how many database statements are executed for my login transaction, and that's great. And I specify in my SLO that the number of database calls or backend service calls should not at all change, because why would it change, right? We don't change login that dramatically. So this is why I get penalized 62.5%. Build number 4 comes along, everything is green again, everything is good. The goal or the point here is the more frequently we can do this automated, the better it is for us, because we can easier detect any type of regression. In Keptn, you specify this through 2 YAML files, a so-called SLI YAML, where you specify what are your SLIs and the query language. Again, could be, like in my case, a Dynatrace query, could also be a PromQL or any other query language that your monitoring tool supports. And then you specify your SLOs. So what is the actual criteria? So basically what I just showed you in the table, just written down in YAML files. Now also interesting here, for the individual SLIs in the objective file, you can give different weights. So you can say error rate is more important than anything else, so you can change the weight. The default weight is 1 for every metric, but then you can change it. And you can also mark individual SLIs as key SLIs. So that means if this one fails, it's so important, then everything should fail. But then how does this process work? If you ask Keptn, do a quality gate evaluation, give it a certain time frame, then Keptn goes off, uses the APIs of your monitoring tools, pulls in the data, compares them against the SLO, and then either gives all the points, half the points for warning, or no points for failed, and then it comes up with a total score, right? And this could be, as an example, 7 out of 8 would be 87.5%, or 4 out of 8 would be 50%. Good. This is the way it works. For Dynatrace already, we went a step ahead and made it easier to define SLIs and SLOs. So you can just build a dashboard now in Dynatrace. And then the Keptn Dynatrace integration is just taking all the charts from that dashboard, all the metrics from the dashboard, and is analyzing these for that time period. So that means it's pulling out the metrics and then it's doing the same calculation, but it's so much easier to create a dashboard first, put the metrics on that are important, and then Keptn is analyzing it. So let me also quickly demo or show this to you, how this works. So I have my dashboard here, right? Just for those that have never seen Dynatrace, monitoring tool, it monitors my environment, in this case Kubernetes, and I have my response time, P95, P90, P50. I have my test transactions, so I'm running my gmeter test is executing 5 tests, and Dynatrace understands test transactions or business transactions, so we can actually tell you individual metrics like response time, failure rate, number of database calls, and things like that per test transaction. So I also added those, also some process metrics, CPU, process memory, event loop tick count. It's a node-based application, so I also added this metric to it. But on this dashboard, right, Keptn just queries and asks Dynatrace, do you have a dashboard for Keptn quality gates? And for my project, for my service, for my stage. So Keptn 07 project, simple node and staging. This should match here. So let me go back to services. Let's go back to build number 4. Then this is it, right? This is my simple node, Keptn 7 project, and it's staging. You can already see here, these are all the metrics that came through. Looks pretty good and solid. Only thing seems to be process memory that is spiking up a little bit. On the bottom here, you also see the individual metrics and also those that violate or not violate your thresholds. So yeah, so this is really just define it. And for those that might be interested in how this works, you can in the tile itself, because it's not just the metric itself, like where does the data come from, but against what do we compare it to. So this is where I say SLI, the passing, the warning criteria, the weight. I could also make it a key equals true. I could change the weight to 5 and things like that. I can also add multiple pass. I can say should be faster than 500 and it should not be more than plus 10% of the previous build. So it should be, the value should be smaller. So if I add a percentage value here, it always goes back to the builds we want to compare it to. And you can also configure that, like, do you want to compare with the previous build or with any other build? You can see here, there's a tile where you say Keptn quality gate total pass. So 90% is needed for total passing score. Warning is 70, compare with, and do you want to compare with how many previous results? In this case, I'm only comparing it with the previous result, but you can compare it with an average or a percentile value across the last 5 builds, for instance. So that's all possible. Good. And yeah, every time Keptn runs and it's time to do a quality gate assessment, we can see here tests are finished. The next thing what it does, it says retrieve the SLIs. So reaches out to the tools, retrieves the SLIs. Once this is done, it then gives me the results here and then uses this to make a decision. And in this case, it looks good. Now we're in prod, and in prod says, hey, approval triggered. Approval triggered means, remember, we have the option to say manual approval or automated approval. It was not automatically approved. So in this case, I can go to my overview here, and I should be able to see, hey, there's build number 4 is now available to be deployed into that stage. I could either click here. We can also automate this through an API call. We currently have some adopters, some Keptn contributors from Citrix. They've written a chatbot for Slack, so you can also get a Slack notification and then say approve. And in the live meetup, we got a question on can you also have multiple approvers? We believe this would be something that we probably want to give to other tools that are out there. There's so many great notification tools that can ask people, and I think it would be another great way to say, this needs to be approved by a certain group of people, and then you use the tools that you use for notifications, and then they can get all the approvals. And once they all approve, then this tool can send back to Keptn, yes, it's approved, right? But now I approve it, and what should happen if I go back here, here we go, approval finished, blah, 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 configuration changed, and the next thing, what should happen, it should actually deploy it then into production. That's the goal, and that's the idea. All right. Another user example. So I've really, in this stage, I focused on the quality gate aspect that is included in the whole end-to-end delivery pipeline, right? But the most important thing here also is you can also use this standalone. Meaning, if you're happy with the current delivery, if you're using GitLab, if you're using, I don't know, Harness, if you're using Xebia, if you're using any of these tools, Jenkins, but you want to automate quality gates, then you could do it like Christian Heckelman is doing it. So he has a GitLab pipeline where he builds, deploys, runs tests, and then he calls Keptn evaluate. So he basically says, Keptn, I just ran a build, I just ran a test, and then now you go off and for that time frame do your evaluation. So that's also a very, it's a great way because we can take individual use cases out of it. All right. Bonus problem number 3. Keptn is not only automating continuous delivery through an event-driven model, but we also try to solve the problem of incident troubleshooting and incident remediation and the problem remediation. Because what we've seen, a lot of people are spending a lot of time in case production problems come in, right? The production problem comes in, you try to get all the people in the room and try to figure out what to do, and then, it's again the log spamming and we need to clear the log, or process crashed, restart, or it was a faulty deployment last night and let's roll back to the previous one. We believe we can also solve this problem through the same event-driven approach for auto remediation, but also using, and this is very important, SLIs and SLOs to validate the impact that the remediation actually had. So to give you an example, and it says here, closed loop remediation coming with Keptn 07. Keptn 07 is already out there, so this is already there, what I show you. If you have something running in production, and let's say your Prometheus or your Dynatrace or whatever other monitoring tool you have is alerting you on a problem, like in this case, conversion rate dropped, right? My monitoring tool can measure conversion rate because we also do real user monitoring. So in this case, I can initiate Keptn, and then in Keptn we have the concept where you can also specify a remediation YAML file. So you can specify basically your runbooks in the YAML file where you can say for a particular problem, like in this case, conversion rate dropped, you want to actually execute a couple of actions. The first one could be scaling. It could be a technical remediation. Let's scale up. Now Keptn will execute that. What's important though is after the execution, it will also re-evaluate your SLOs. Now I also say here BLOs, business level objectives, because we can also obviously include business metrics like did the conversion rate actually go up again, or whatever business metric you have. Now if this doesn't work, then Keptn goes off with the next action, for instance, stopping the campaign. Making an API call, for instance, to the Google ad manager to say, let's stop this campaign. Then again, evaluating, right? What did this do? Are we not wasting money anymore on things that we shouldn't waste money because we have a challenge right now? If none of this helps, then we can obviously still escalate. And here again, it's event-driven. That means these actions that you see here are just Keptn sends events and say, I need somebody to do a particular action, and then the action is picking it up. So you can also create your own actions. We had questions in the live meetup where somebody said, are you replacing Chef Puppet Enzyme? I said, no, we're not replacing them. We are integrating with them. Keptn is orchestrating the execution of remediation actions. So Keptn is triggering Puppet Chef and Ansible, or Relay, or is triggering X Matters, or is triggering any other tool, ServiceNow. but then Keptn is keeping an eye on that problem because it keeps reevaluating if the problem was actually solved or not. And if it was not solved, then it goes off and execute the next action here. One example, again, custom example. Abigail, she's a site reliability architecture CFA Institute, and this is something we're planning for this year. So they're using Launch Darkly for feature flags, and their goal is when they turn on a feature flag, and then for whatever reason in the middle of the night or some problem is detected by the monitoring tool, then we're integrating this with Keptn, and then Keptn can, as I said earlier, either do a technical remediation first, like scaling up, or turning off the feature flag, for instance. Turning it off, up, and the problem is gone. All right, so let's wrap it up. What is Keptn? Keptn is an event-based control plan for continuous delivery and automated operations. And it says here for cloud-native applications, but as you have seen, this is not entirely true because you can use Keptn also for any type of application, right? You can let Keptn also call a Jenkins library for deploying your J2EE app somewhere. But initially, obviously, we focused with Keptn to solve cloud-native problems or problems in the cloud-native space. But the way we now architectured it, you can use Keptn for any type of app. That's the nice thing, thanks to its event-driven model. So the benefits and also the problems that I highlighted today, we have a separation of concerns, so you can define the process of what should be executed, in which, how many stages you have and what should happen in each stage. You do this all declaratively, right? That's important. We're using predefined cloud events to separate the process from the tools, right? The process is managed by Keptn, but then Keptn sends events that are then picked up by the tools. And it's super easy to integrate and switch between different tools, because the only thing you need to do is you need to write a Keptn service, as we call it. That is just a container that you deploy in your Keptn names, in your Kubernetes cluster. It's subscribing to those events, and then it's reacting to it. And it's also easy to integrate it in your ecosystem, because Keptn itself, as you saw, has an API, and you can then also from the outside trigger Keptn workflows, either the whole end-to-end, or maybe just quality gates. You can also do test and quality gate. You can do the whole delivery, or you can just focus on auto remediation, whatever you want. The best way to get started is tutorials.keptn.sh. A lot of great tutorials out there. And yeah, most important thing is, we need feedback. We need to learn from you. Are we actually solving a problem? What other tools are out there that we should integrate with, or that should integrate with Keptn? What things are we missing? Yeah, I think that's, and also, help us also contribute with actual code contribution. Check us out on GitHub. We have weekly community meetings with the development team on a Thursday at 5 o'clock Central European time, which is 11 a.m. US Eastern, comes together. We have regular Keptn webinars where we actually have end users talk about how they are using Keptn. We have a Slack on keptn.slack.com, slack.keptn.sh. But we also have a Slack channel on the CNCF Slack. So if you happen to be on CNCF, check out the Keptn channel there. Yeah, normally yesterday when we did this live, we went into Q&A, and I think that this went on for at least 10 to 15 minutes. I think I covered a couple of questions already that came in. So we can to reiterate some of the questions. How do you compare to Spinnaker? We're not replacing Spinnaker. I believe we are the best. We allow you to take the best tool for a particular job, and if this is Spinnaker for delivery for you, then it's great. Then you may want to use Keptn as an end-to-end orchestrator, or you have Spinnaker, and at the end you want to do your quality gates. Call the quality gates, or you just want to use the auto remediation. Then do this. If you're not happy with Spinnaker, then obviously look at what we have to offer with our Helm type of deployment. The other question that came up was how do you authenticate against Keptn? I think let me just quickly show this. You authenticate through API tokens. So right now, both for accessing the bridge, obviously username, password. Right now it's single user, so we're still in the early stage. Single user, username, password. There's more coming. For the API, you get a token and you get this out at the installation. So this is the way how you would authenticate. The other question that I can remember was, what was the other question? Jenkins, yeah. There's a lot of Jenkins material out there. That's what I wanted to show you. There's one that's called Keptn Sandbox Jenkins Tutorials. So this is where I've created a couple of tutorials on how to integrate Keptn with Jenkins, right? Have a look at this. Also with animations and links to a video that I did and all that stuff. Good. Yeah, I want to leave it with this. I want to say thanks again for the opportunity that I was given to actually present at this meetup. We would be very happy to get feedback from you, try it out. There's a lot of cool installation options, very easy to get started. And yeah, I think we are a still young project, 1.5 years young. And there's clearly a lot of things we can do from now on, but we need your feedback to know in which direction we need to take this. But having said that, thank you so much and bye-bye.